So on page 59, I'll just ask you, don't use up the whole page. I might add some more, so I'll basically add like a 2x3 box. That's what I would start with. Like a 2x3 like that. Thank you. And then, but we've done a lot of ands, this and that, and that's just it. There's just one bottleneck. But so what we're gonna do is we're gonna add, should we add a 3x3? So I'll go 1, 2, 3 sort of. So I'm kind of making a 3x3 and add it on like that. So basically what you want to do is have it so that they share one box here. That's basically where you what you want to create if possible. And so the question, it doesn't really matter if I start down here or up there, but let's say you're starting there, you want to go from A to D. Sometimes there will be nothing, no letters here, but that is the assumption that you're having two ways to get to D, right? Two stops along the way. So we'll go stop there, stop there. So this will be B and this will be C. Okay. So how many ways are there to get from A to D? You can use the formula, you can use the counting method, whatever you feel like doing. See if you remember how to do this. And you have your notes, right? You got to just go back to the pathways and see. Essentially what you want to do is focus going through B first and then focus going through C next, right? You got to add those answers up. So I'll give you time. That's all you can do, right? Sometimes. And but don't leave it blank. Okay, so we got to go. We first have to consider this is an OR case, so we got to go A to B, then B to D. And we're going to figure that out. Or A to C, and then C to D. Oh, okay. Unfreeze. There we go. Sorry, you couldn't see what I was doing. So let's start again. A to B, and then B to D. Right? So and. Because you're going from here to here and from there to there. Then you have A to C, so AC, and then CD. So this is basically what I'm going to be doing here. And yes, from A to B, you almost have to ignore everything else. So from A to B, we've got 1, 2, so 3, 4, right? There's 4 blocks that you're walking, divided by 3 factorial, 1 factorial. So the numbers down here always add up to that one, right? That's another pattern. But it does matter. You've got to get them in the right place, right? And then B to D, now I'm focusing just on this here. So we've got 2 and 3, that's 5 factorial over 2 factorial and then 3 factorial. Plus A to C. So now you're basically blocking everything else. You're just focusing on that square that's created there. So that's 4 factorial over 2 and 2 times, right? C to D, you focus on that. So that's 5, and it doesn't matter. You can go down and then sideways. It doesn't matter. It's 5 factorial over 3 and 2. Okay. And essentially, you can tell that there's a copy. Like this is basically the same here. Right? These two numbers should be the same when you compute this. So anyways, I think this is the time to maybe I don't know if you want to do this or not, but on your study sheet, if you want to have like a cheat like 2 factorial is 2, 3 factorial is 6, 4 factorial is 24. It just, because a lot of these are quite frequent, right? 6 factorial is 720. And then 7 factorial is Somebody help me out. What is it? 5,040? Thank you. And that's where I would stop, right? Those are the most common. So then you're saving yourself having to type all these like in every time and finding the factorial. Some of you just memorize it, that's fine. But you got to know, like, end of the semester, you're probably going to forget. So if you have it on your study sheet, it doesn't take up that much space. Anyway, so 24 divided by, this is 6. 6 times 1 is just 6. This is 120 over, this is 2 times 6, which is 12, right? And or, you've got 24 over 2 times 2, which is just 4. You shouldn't get decimals. If you get decimals, check, right? 5 factorial is 120, and then it's 6 times 2, which is 12. So this is 4 times 10 plus 6 times 10. Hey, looks like it's 100. 100 ways, right? Or paths to take. And counting method would also work, right? So if you did it that way, it should jive. Should I do it once? Okay, I'll do it. 1, 2, 3, 4. This 4 gets carried on like this. And then so this is 3, 6. This gets carried down this way. So 6 and 4 is 10, 14, 18, 16, 30, 48, 22, 52, 100, right? So regardless of how you do it, you get that. So don't forget about the or. Should I say hint, hint? I never said anything. It's not on record either. Okay. Anyways, so watch for, just review this one. Be ready for this one. You're pretty good at the ands. And just one bottleneck. The ors, I think practice is probably good to go back and try one. All right, let's do this one here. Let's copy this down, and it's still a work in progress, so I'm gonna add to this, but I'm just gonna stick to 59 right now, page 59, and then see if I need more space. So I would put this as close to my diagram as possible so we have a lot of space underneath. So if you could write this down, I just made it up. The zebras talk, made me forget about what we're actually doing here. 16 total, and we have subcategories. Notice that. How many cards in a deck of cards? 52, but do we have subcategories? Right, we've got clubs, we've got face cards. So think of it the same way, okay, same way. So how many groups can be made? 16, choose, we're gonna choose 4, right, groups of 4. So that's it. Like if you just want groups, I have no idea what the answer is. It should be 1820. 1820? Okay, thank you. Oops. Okay, so now I'm gonna add layers to it. What if you wanted exactly, and I'm summarizing, I'm not gonna write out the whole thing to save us time here. What if you wanted exactly 2 pigs in the mix? Groups with exactly 2 pigs. How would you do that? How would you show your work there? And I'll tell you the most common mistake I see. They're like, oh, pigs, I've got 5, choose 2, right? 5, choose 2, and that's it. Like students are like, that's it. I have exactly 2, but your group isn't complete. So you always got to think like, what else do I need? Right? I need to choose another what? Another 2, correct? To make my groups of 4. So 2 and 2, that's your group of 4. So that's what you look for right there. And what else needs to come in here? What are we going to put there in front of the second choose? We're no longer picking out of the pigs anymore, right? We're picking out of the, what, 4 and 7. There's 11 animals left to pick from, okay, guys? So we picked from the 5 picks, we picked 2. choose and pick. I wanted to mix that up, didn't work so well. And so from the, what is that, 11? From 11, choose 2. That's how you would solve that, okay? And watch this, I'm gonna go and combine these two and saying, this is my total. Total is 16. So you gotta, both dynamics here, you gotta fulfill the requirement of my group, you gotta fulfill the requirement of the total, all right? So what would this be? I'm gonna use this one because it's a lot faster for now, okay? 5 choose 2 is 10, so it'll be 10 times 55. So that's 550, right? So these many groups would have exactly 2 pigs in them. Let's change it up now. Groups with at least, what am I going to say, 1 goat. Groups with at least 1 goat. This one is going to be worth 2 marks. If you see 2 marks, you're like, there's more than meets the eye there. Anybody willing to say how you would solve that? Jessica, can you repeat that? I tried to read your lips. Yeah, you would use indirect reasoning. And I get it. Like, I've seen this many times, you haven't. Can I rephrase this for you? If it says at least 1 goat, correct? Out of a group of 4, in other words, you're saying 1 goat or 2 goats or 3 goats or 4 goats, correct? That's what this question is saying. Make me groups that have either 1 goat or 2 or 3 or 4, right? That's what this question is saying. So what I'm going to focus on is this. Instead of figuring out every single case, that's direct, like adding these up, I'm going to go total groups possible minus 0 goats. Okay? Or you can write down no goats because you might be like, what's all goats, right? Is that like a Cheerios cereal or something? Anyways, total minus 0 goats. So I'm going to go 16 choose 4. That's my universal. Minus, let's create the group that doesn't have any goats in it. So you got to be specific here. Out of the 7 goats, you're going to choose none of them. 0. And what remains? You can do it in 2 ways. You can either just say, well, 5 and 4, that's 9 that aren't goats. Or you can just take 16 minus 7, that's also 9. But from the 9 remaining animals, I'm going to choose all 4, because remember, you have to have your group of 4, and you have to have the 16, the total, right, always. So if I take total minus no goats, then I have everything else that remains. I got rid of the no goats, everything remains, okay? So let's figure that out. We already know that this is 1820, the first one. We're gonna go minus 7 choose 0 as always, 1, 9 choose 4, that's 126. So it's basically 1820 minus 126. That's 1694. Let's add another layer to this. Groups with, if you run out of space, try to see if there's another page after this, or you can use the backside. Groups with at most 2, we use the pigs, let's do horses. How many groups with at most 2 horses would you have? This one would take you even further. So I would say this one would be worth 3 marks. At most 2 horses. So remember, you always have choices to make, right? So let's rephrase this. If you see this, if you see at most, it's like the most you can ever have is 2 horses. So it's saying 0 horses or 1 horse in the group or 2 horses. I think I'm going to use direct reasoning here. I'm just going to add up the cases. So I'm going to figure out the no horses, 1 horse, or 2 horses. Can you write it out? Translate this statement using combination notation. Like, can you write that out? Just give it a try. Remember, you want your 16s and you want your 4s always together. Want me to do the first one? 0 horses. I would go from the 4 horses. I would choose none of them, which means how many are left? There are 12, correct? I'm going to choose all 4. You finish that statement. It's very important for you to know how to do it. Not okay. I'm going to continue here. There we go. Choose 4. So this whole thing gives me 495 plus this gives me 440. Four choose 2 is 6.
Yeah, see what you're doing. The screen is broken.
Let it go, let it go. Anyways, I keep forgetting that. Sorry about that, guys. Let's do this again. It's on the video, but it won't be, you guys couldn't see it. So this is 495. That's what I get here. When I multiply this out, I get 440. I know 4 choose 1 is just 4. 12 choose 3 is 4. It's 110, I guess. Right, and then I will compute this here. 4 choose 2 is 6. And then 12 choose 2 is 66. So it's 396 here. So if you add all of that up, 396 plus 440 plus 495, that's 1331 groups. With at most here I don't use indirect here. I just flat out focus on the cases that this question is considering, right? At most 2, so 0 or 1 or 2. Okay. Isaiah, I heard you say I got the same thing. Did you use indirect reasoning? Oh, you got something else. Is it one of these? Is one of the is the write out wrong here, or what do you see? 16 and 4, 16 and 4, 16 and 4. Is one of these numbers different for you? The entire thing. Anybody else get something other than this number? You got something else?
Yeah. The second one.
This one? 880. Come on. Thank you for yes, 220 times 4, 880. Sorry, guys. There goes that, eh? I'm just showing you, how to react to mistakes, right? You just suck it up and you're just like, okay. There you go, 1771. Right? Is that? Let me know. And that's it for this one. So I want to talk about deck of cards, though. Let's go. I'm going to go back a little bit. Was it in the worksheet that I have? No. Okay. 48. If you watched my video on this is probably already filled in. But I thought I'd just park there and just make sure you, if you're not very familiar with the deck of cards, I would strongly suggest you add this little piece to your study sheet. Right? So you've got 52 cards, 26, 26, right? Red and black. And then every single, like within the red, you've got your hearts, diamonds, clubs, spades, right? And they all have ace, 2 to 10, jack, queen, king. Maybe I should say every single suit has 13. I don't know if you need to write that down. Each of them has 13. And there's 12 face cards, right? 3 in every suit and 4 suits, that's 12. So face cards are also important. So maybe I will add that later on to this. I'll add some questions with deck of cards right now, okay? So if there are no restrictions, if it's hands of 5, just read the question. It could be hands of 6, of 7, it doesn't matter, it depends on the game. From 52, choose 5, no restrictions. This is probably blank in yours, correct? Most likely. So this is 48. You can have at most 1 black card, not cards. You can have at most 1 black card. When it's at most, translated, like what is that saying? It says either 0 black or 1 black. Right? This is or. Okay. So that's basically my order of business here. This is how I'm going to approach it. So let's say this is a test question right now, right now. How would you answer this? How would you approach it? You first want to meet the requirement of the black cards. Okay? So we have 26 black cards. Is this a choose question? Yeah, because it's hands of cards. It's groups, right? We don't really care if the ace is up front or in the back. It doesn't matter. If you have the ace, it's in there. Ace of club, of whatever. Okay? So we've got 26 black cards, and we choose 0, right? And what is left? If you have 26 black cards, then we have 26 reds, and we're going to choose all 5 of them from the red stack. Okay. I'm going to translate it up here. 0 black, 5 red. That's what's happening here. 0 black, 5 red. Plus, from the 26 black cards, I'm going to choose 1. And from the 26 remaining red cards, I'm going to choose 4, right? So always remember, you've got your hand, and this is the total, right? Here you've got your hand of 5, and you've got your total. It should always jive, right? If the total is 52, then it should always be 52 when you line that up. Okay? So that's how I would approach this one. That's what this question is asking. So we're going to go 26 choose 0 is just 1. 26 choose 5 is 65,780 plus 26 choose 1 is just 26. You can try it out just to make sure. and 26 choose 4 is 14,950. Let's clean that up one more time. 65,780 plus 388,700. That's 454,480 hands. Can I add a question here? Looks like you will have enough. Your writing is a lot neater and smaller than mine, so let's add a question here. You have I'm going to change this up. At least one face card. How would you answer that one if you wanted all the hands that have at least one face card? Remember, it's at least one. So I'm going to use indirect. I would use indirect reasoning here. I would say total minus no face cards, no faces. That would be my approach here. That's the quickest way to do it. So I'm going to ask you to try that right now. Make sure you use a pencil. All right. I already have the answer to this, right? 52 choose 5. That's total. That's like everything. Everything that you can imagine. Every hand you can possibly be dealt. So minus no faces. So I'm going to focus on my faces. I have 12. Choose 0. I'm going to choose none of those. And then from the, how many remain? 40, right? I'm going to choose all 5 from those 40. Okay, so that gives me, I'm going to write out the 2,598,960 minus 12 choose 0 is just 1. 40 choose 5 is 658,008. Are we good there? We're good? Okay. 2,598,960. That's, I need your feedback when I make stuff up, okay? 952. Hands. Okay. If you review and you go through your booklets, and there's the crazy questions where you've got repeats, and then those repeats have to be at the front of the password, and it has to be even, and blah blah blah. Like, I won't do those really. I won't have too many conditions at the same time. It's a nightmare to mark, and the province doesn't do that because they want to see like if we give you that one condition, can you meet that, right? So don't focus too much on those ones. Just know how to make your passwords, make sure there's no repeats and stuff like that, right? Okay, well, I'll just talk briefly about this yellow handout, and then we'll do passwords to end. It's going to be my grand finale. So the yellow handout, perms and comms overview. If you have it, if you want to follow along a little bit, I'll just tell you what I was thinking when I made this thing. So when order matters, it's usually, we call that a permutation. So the question will be mentioning specific roles, like either for a team, like forwards, left wing, right wing, whatever, president, vice president, treasurer. Those are like classic giveaways. Lining up for pictures, passwords, codes, postal codes arranging objects, people, pictures, cars. If repetition is allowed, then it essentially, I would just say, use the fundamental counting principle, and it's n to the power of r. N meaning the number of options you have for every slot that needs to be filled. Okay, that's usually what it will look like. Like, let's say you have 26 letters, it'll be 26 to the power of 4 here. R is the number of slots to fill. Okay, if repetition is not allowed, so you have either a limited supply, you're told you have a deck of 15 cards numbered 1 to 15, or people, or something like that, you can't keep using the same person over and over. Then sometimes we have passwords, creating numbers, letters in a word, people. You're limited. Just make sure. Then we can use fundamental counting principles still, but we use NPR as well, or factorial, right? If factorial, you only want to use if you actually have, if n is equal to r. What is that, Mr. Dixon? Let's say you have 14 people and you just want to line them up. Right, there are 14 slots to fill 14 people. So then it's just 14 factorial or 14 pick 14. It's up to you. But if you have 14 people and you just want 5 at a time, 14 pick 5, right? Or you do your 5 slots and just fill it in with the numbers there. If order does not matter, hands of cards, like that these keywords should probably be on your study sheet if you struggle with determining what needs to happen. But these keywords tell you, oh, okay, we're in the combinations territory. Okay, and then making groups R from n available. So you use NCR like this, or sometimes the province has used this notation. I'm not going to ask you to use this notation, but you need to be able to read it if it's there. Maybe just a refresher. Hands of 6 with 2 red cards. What they really mean is, right, 2 red cards and 4 black. Like if you're making a hand of 6 and it says exactly 2 red cards, well, you should know that it needs to be filled with whatever remains. Okay, that's what I mean here. Let's talk about when you follow this branch, there's like a bunch of things that were covered under this branch. So we have one or more condition that overlaps, or do not overlap, sorry. If condition overlaps, or if it's like saying starts with this or that, you have to split it into cases. Grouping, this is when you group them in a line. Okay, guys? So I was just thinking, hey, there's grouping here and grouping there. What's up with that, Mr. Erickson? You said grouping is always combinations. This is when you're lining up for a picture and you and your friend want to be together, right? That's the kind of grouping we're talking about here. Or 3 of you want to be together, whatever. So that grouping where you still know where order does matter, that's when you use that formula G1, G2, like the groups that you've created. Look at your quiz for that. We did a lot of grouping there with the CRVs being together and whatnot. Identical or indistinguishable objects, you got to make sure you divide out the identicals. Okay, look at the marbles question in the quiz. You have to divide out stuff you can't tell apart. Letters, right, in a word that are doubling up, you got to factorial that and divide it out. This is your pathways little block here, which we just did today, but there's no bottleneck. This one is the easiest. This one is literally just a rectangle like that. No bottleneck. One bottleneck is when you have just one bottleneck, that's this one. And the ors is when you have, I'm going to try my best here, but you have 2 bottlenecks. Okay, that's the or. So those are your 3 cases there if you want to write that down. And then the scary box at the bottom here, this is just reviewing direct and indirect. But if you got what I was saying today, this is probably the most important one right here. This is the most commonly used by the province, by us, right? Password with at least one repeated letter. You would go total minus no repetition to figure out a password that has one or more repetitions. Okay. And I talk about indirect versus direct. So those are your two options. You choose what you want to do. Both work if you do it right. Okay. So that's it. That's all I wanted to do with this yellow. If you're like, this didn't really help me, you check it. Use it to start your campfire in the summer. Works. Okay. So we're gonna go back a little bit. I know I'm aware of my time here. I'm gonna go to 43. Read that question real quick. I'm gonna change it just for time's sake. You've been hired by a company, and you're told that your login password must be between 4 and 6 characters. This makes the question very long, because that means you can make a password with 4 or 5 or 6 characters, right? So I'm gonna just say let's all agree on 5 characters. Change the 4 to 6 and just say, hey, we're just gonna make a password with 5 characters, that's it. You can use digits 0 to 9, not 1 to 9, right? Letters and special characters. This is important that you're prepared for something like that. How many password combinations are possible? So figure that out and then try already B. This is an indirect reasoning example as well. So go for it. I know I'm not giving you enough time usually to solve the whole thing, but I just want to make sure to wrap this up before we go. So how many password combinations? 1, 2, 3, 4, 5. So watch this. There's 10 digits, 26 letters, and you've got 4 special characters. So that adds up to 40 options, doesn't it? I didn't specify case sensitive, right? If it had been case sensitive, we would have multiplied the letters by 2 to get our 50. So 52, sorry. So we've got 40 options for each slot. So this will be, it doesn't say we can't repeat. So we're just gonna go like this. This is where the 40 to the power of 5 comes in. Big number. That's how many passwords are possible. Repetition, no repetition, it has everything in it, right? It has everything in it, everything you can possibly come up with in this scenario. So I'm gonna, in preparation for this one, I'm gonna already do passwords without repetition. That's usually a classic. Like, how many passwords do not have any repetition? So you have a choice to make. It's either like this, using the fundamental counting principle, or you go 40, pick, not choose, pick, 5. And it should be smaller, right? Because you're restricted. That's how many passwords do not have any repeated characters or digits whatsoever. And also, this password does not really specify that the first one has to be a number and then so forth. It's just all combined. You can just use any combination of what you want. So this prepares me for this. At least one repeated character. How many characters do you have? 40. So, right, you have so many to choose from. Direct would be insane. Doing the direct reasoning would be very, very time consuming. So I'll go total minus no repetition. In this case, I did that already up here. But if it doesn't, let's look for the number of marks attached to it. If it's just a 1-mark question, it usually means that you already calculated without repetition before. If this had been a 2-mark question, then it's probably expecting you to figure this and then subtract. Okay, so that's usually how it goes. So this would be 40 to the power of 5 minus 40 pick 5. $23,439,040. This is my final answer. Okay. So I know I've been focusing on indirect reasoning and some direct reasoning, so just keep that in mind. It works nice to review because we do everything else as well, right? We do all of these ones. The next one had this one here. I probably won't solve this. I'll just show you how to set it up. So let's go to the next one here. You have won the lottery. You bought 2 Mercedes-Benz, different models, so they're all different. 4 different Jaguars and 3 Toyotas. The idea is that they're all different. Your chauffeur wonders how many different ways he can park the cars if you give no restrictions. What would you use here? Right? You've got 2 and 4, that's 6. You've got 9 cars. Okay, 9 cars available. So if you want to park them a certain way, it doesn't matter the order that you park them in. It's a different permutation. So in this case, it would just be 9 factorial or 9 pick 9. It's however you want to do it. Or you do the 9 slots, fill it in. What's 9 factorial? 362,880 ways. Order matters. Okay, you're not making groups. How is that? Like you're thinking, oh yeah, you're not making groups. You're parking them. You're arranging them. Okay, this is permutation, right? So keep that in mind. And you have a limited supply, right? You only have that many cars. So as soon as you use 9, then you only have 8 left, and then so forth. You want the same makes together. Grouping. I should say grouping, but not combinations. Okay? You gotta watch out for that. So 2 factorial, 4 factorial, 3 factorial. So all the same makes are together. Then I open this is the square bracket perhaps in the formula I gave you. You have 9, you subtract everything. You basically are subtracting. Did I get this right? Yeah, okay. Yeah. So you subtract the 3 values of those subgroups, then you add the number of groups you've created, which is 3. Make sure you have a factorial at the end of that one. Okay, so really your answer should look like this. We can probably do this. 2 times 24 times 36. 2 times 24. It's 1728 ways. And I'm going to change this last one. Oh no, I'm going to first do this one, then I'm going to add another one. Or are you sick and tired of this already? Maybe you are. You would like the Jaguars to be grouped together, so we have 4 of them. This is my last bracket here, so I go 9 minus 4 plus just 1 that I've created. So this is 4 factorial. 5 plus 1 is 6 factorial. Okay, that's how you would find it. That's 17,280 ways. And D. Jaguars, watch this. Jaguars not together. How many ways could you park the cars where the Jaguars are not parked together? We already know how many ways there are where they are together, correct? We already know all possible ways of parking the cars. What are we going to do with these two? Subtract, right? So we go 9 factorial minus 4 factorial, 6 factorial. What I don't want you to do is try to figure out, oh, how many ways are there to not park them together? And then don't try that. Just use indirect reasoning, and that's the way to go. 345,600 ways. Where they're not going to be grouped together because you got rid of the options where they are together. All right. For review, I will give you a handout that you can try. I'll post the key if you want to go through it. There's a test in the textbook. I'll write it at the very front of your booklet. Okay. There are some pages that have some good review materials. So if you're ready for it, if you go page 293, so this is review. Page 293, there's a bunch of questions there. There are some equations there. It goes to 294 as well. Okay, that's probably a good test review. And the handout that I'm going to give you, if you want to do that, that's fine as well. One more thing. There's going to be a Venn diagram to fill. Okay, so I'm going to give you a bunch of information, and you just have to know how to fill it in completely, including outliers. Okay, it's not going to be a very crazy one where you have to it's just like, here's the information, do you know how to fill it in? Okay, if I have time, I will make a short 5-minute video. I wanted to go over it today, but I ran out of time. I will do that question. If you want to just review how to do it quickly, I will make a short video on that if I have time. Okay. Have a good one, guys.